Okay, we're going to wrap up section 1.8 on solving other types of equations with solving equations that are reducible to quadratic equations. So basically what I mean by this is sometimes you can take an equation and you can actually write it in the form AU squared plus BU plus C equals 0, and then you can solve for U. And then at the end you can solve for the original variable. So what you have to do is you got to understand that U is actually some sort of substitution that you're going to make within the problem. The key is recognizing, like for instance here, recognizing that this term x to the 2/3 is actually the same as this term squared. In other words, another way to say that is that this is x to the 1/3 quantity squared, because if you squared x to the 1/3 you would actually get x to the 2/3. So anyway, that's what you have to recognize there. And so once you recognize that, then what you can do is you can let this be u, let this part, not the coefficient, just this variable portion, be u. And we just discussed what u squared was, right? U squared is this. So if you let u equal x to the 1/3, then automatically u squared is x to the 2/3. So you can replace x to the 2/3 with u squared. You can replace x to the 1/3 with u, and then you just keep your minus 2 equals 0, and then you can solve for u by factoring usually. Now you might have to use quadratic formulas sometimes, but here we're going to solve by factoring. So if you solve this by factoring, you get u, this actually factors into u minus 2 and u plus 1, and since you've got this is a product equal to 0, you can set u minus 2 equal to 0, which I didn't do because I figured you could do that in your head. But u minus 2 equals 0, and then solve it and you get u equal 2, and then u plus 1 equals 0, and you get u equal -1. So those are the two values for u. Now here's the problem. Many students stop there and they get the problem wrong because the original problem is wanting you to solve for x. So this is important. You must move on and solve for x. Now that's not hard to do because you know what u is. Up here, u is x to the 1/3. So u is 2, right? Well, if u is 2, but u is also x to the 1/3, well then if u is 2 and u is x to the 1/3, then x to the 1/3 and 2 must be equal. So if u is equal to 2, then just replace u with your original substitution, x to the 1/3 equal 2, and then solve it. And now you can solve this because all you have to do to eliminate this exponent is cube this side and cube this side. So if I raise this to the 3rd power, it eliminates the 1/3 power and gives me x, and then 2 cubed on the other side gives me 8. So that's one of my answers. Now, same thing here. U is equal to -1, right? But I know that from up here, u is x to the 1/3. So replace u with x to the 1/3, and I have x to the 1/3 equals -1. And then apply the same property here as I did over here by just cubing both sides, and I get x to the 1/3 cubed equals -1 cubed, so x equals -1. And so there I have two answers, x equals 8 and x equals -1. There's many problems that you could do this kind of stuff on that I could show you, but I don't have time to show you every possible variation. Here's another one. Again, the middle term, the variable in the middle term is y to the -1. The variable here is y to the -2. Well, actually y to the -1 is the same as saying, y to the -2 is the same as saying y to the -1 squared. So really, this y to the -2 is the same as this y to the -1 squared. And so that's the key, because if you think about a quadratic equation, you always have, like, this variable is a square of this variable, and that's what we've got here. So these aren't quadratic equations, but they can be reduced to a quadratic equation in this form. So what we're going to do is we're going to let this be u, so u equals y to the negative 1, and then of course if you square u, you get y to the negative 2. So we can replace y to the negative 2 here with u squared. We can replace y to the negative 1 here with u, and bring the 16 down, and then of course equals 0. And then we factor this, and this factors into u minus 16 and u minus 1, and since that product equals 0, then either u minus 16 must be 0, where u is 16, or u minus 1 must be 0, so u must equal 1. So your two answers for u are 16 and 1. But again, don't forget, you're not trying to solve for u, you're trying to solve for y. So we have to replace, so here we're going to solve for y using u equals 16. But remember, u and y to the negative 1 are the same thing. So if u equals 16, then y to the negative 1 equals 16. And the easiest way to get rid of this negative 1 is just to raise y to the negative 1 to the negative 1 power. Because you're going to multiply exponents, and negative 1 times negative 1 is what? Plus 1. So you just get y to the first, which is y. And then 16 raised to the negative 1, well, that's just the reciprocal. 16 to the negative 1 is just 1/16. So you get y equals 1/16. Now this one's actually easier, but you still do the same thing. You have to do it for u equals 16 and u equal 1. For u equal 1, of course, remember, u is the same as y to the negative 1, so we have y to the negative 1 equals 1. And then raise both sides to the negative 1. Well, we know y to the negative 1 raised to the negative 1 is just y, and we know 1 to the negative 1. It's just the reciprocal of 1, and what's the reciprocal of 1? 1, right? So y equals 1. So there's different things that you could do. I mean, like you could take something like you might even see something like this. Let me pause the video and let me show you. Okay, I just threw this one in. Suppose you had a binomial 3x minus 1 quantity squared plus 3 times the quantity 3x minus 1 plus 2 equals 0. Now I realize you could multiply all this out and probably turn it into a long polynomial, but let's just say you recognize that this 3x minus 1 is just this guy squared. So you could let u equal 3x minus 1, and then you could replace this with u squared, and you could replace this 3x minus 1 with u, and then you would just have u squared plus 3u plus 2 equals 0. And then you could factor it. I'm just going to kind of wash over this. You can factor it, set your factors equal to 0, get u equals negative 2, u equals negative 1. But then you would have to go back to this guy and replace u here with 3x minus 1. So you'd have to solve 3x minus 1 equals negative 2 and do the same thing for u equals negative 1. And you get 3x minus 1 equals negative 1. Then you would solve those two for the answers for x. And so, you know, like I said, there's lots of different ways that you could do this type of U-substitution. Okay? I'm going to show you a real nasty one. And the only reason this one's nasty is because to get all solutions, that means real and non-real solutions, then it's rather tricky. Okay, so let's take a look at this. X to the 6th minus 7x cubed minus 8 is 0. Now notice that x to the 6th could be written as x cubed squared. Right? So x to the 6th is just the square of x cubed. So I could let u be x cubed, and then u squared is x to the 6th. So this is just going to be u squared minus 7u, all right, minus 8 equals 0. And now factor that, and you get u minus 1 times u plus 8. I mean, those are the factors. And you can set them equal to 0 and get u equals 1 and u equals negative 8. But u is x cubed, right? So if u equals 1, then that's the same as saying x cubed is 1. U is negative 8. That's the same as saying x cubed is negative 8. let me separate these here. All right, so now I know what you would like to do. You'd like to just say, oh, the cube root of, just take the cube root of both sides, you get x equal 1, we're done. Okay, same thing here. Take the cube root of both sides, you get x equal -2, we're done. Well, that would be fine if you just wanted the real solutions. But let's look at what happens if you move the 1 over here and create difference of cubes. Difference of cubes. Now, from a lower level algebra course, you'll learn that difference of cubes will factor. This actually factors into x minus 1, x squared plus x plus 1 equals 0. And if you set x minus 1 equal to 0, you get your x equal 1, just like we said you would. But then if you set this equal to 0, you actually have to use the quadratic formula, and I'm not going to do that here, but a would be 1, b would be 1, c would be 1. And so you would actually have to use the quadratic formula to solve this, and what you'd find out is you get two non-real solutions here. You get -1/2 plus or minus the square root of 3 over 2i. So basically there's 1, 2, 3. There's one real and two non-real solutions. Okay, now let me just walk you through this and say, okay, if you go through the same steps here, you're going to factor this using sum of cubes formula, and you're going to get x equal 2, but you're also going to get, x equal -2 is what that should be. You're going to get x equal -2, and then when you solve with quadratic formula, you're going to get x equals 1 plus or minus I square root of 3. And so that's basically the 6 solutions there that you would have. You have 2 real and 4 non-real solutions. Okay, there's some mowing in the background. Hopefully you won't be able to hear it here, but I'm going to finish up this section. Just talk about factoring real quick. X to the 4th minus 1 can be solved by factoring. You just factor x to the 4th minus 1 using difference of squares. It factors into x squared minus 1 and x squared plus 1. But then x squared minus 1 actually factors as difference of squares into x minus 1, x plus 1. And so you have these 3 factors. This doesn't factor over the reals. So let's set each of these 3 factors equal to 0. X minus 1 equals to 0 leads me to x equal 1. X plus 1 equal to 0 leads me to x equal -1. And x squared plus 1 equal to 0 tells me x squared equals -1. And then if I apply the square root theorem, I get plus or minus the square root of -1, which is plus or minus I. So I get 4 solutions, 1, -1, I, and -I. This other one, I need to move the 4x cubed over. Don't go through here and divide everything by x cubed, because then you're dividing by 0, and that's not allowed. So move the 4x cubed over, and you get x to the 4th minus 4x cubed. Factor out the x cubed, and you get x cubed times x minus 4. Set x cubed equal to 0, you get x equals 0. Set x minus 4 equal to 0, you get x equal 4. 2 answers there. Here, you can factor this by grouping. These first 2 terms, factor out the x squared, and you get x squared times x minus 3. These 2 terms, factor out a -1, you get -1 times x minus 3. Take this x minus 3 and factor it out of these 2 terms, and you'll get x minus 3 by itself, and inside you're left with x squared minus 1. And then in the next step, factor x squared minus 1 into difference of squares, x minus 1, x plus 1. And then set this equal to 0, you get x equal 3. Set this equal to 0, you get x equal 1. Set this equal to 0, you get x equal -1. And that's pretty much it on solving other types of equations. I'll leave it up for just a second, let you look at it. Goodbye.